Hello there, college algebra students. This is Mr. Kashi speaking. In this video, we're going to be going through our first day of 10-2, which is on arithmetic sequences. So we've talked about sequences before. Today, we're going to talk about specifically arithmetic sequences. And what arithmetic sequences is, they're a sequence that have a difference between successive terms is constant. So basically, what this means is that they're adding or subtracting the same number each time. And the constant that it increases or decreases by is that common difference. And so, so here, if you take a look at this first sequence, we're starting with 2, and then we're adding 3 each time. And then if we were to find the next 4, you could say, okay, well, adding 3, we got 14, and then we have 17, we have 20, and then 23. And you could keep going. And so this is what we would call our first term, which is A1, and then all the way to our, this would be A8, that would be our 8th term. But what we have to do is, what if we wanted to find the 50th term or the 100th term? I wouldn't want to keep adding 3 each time. So we can do that. We can find these terms. There's a little shortcut using this arithmetic sequence formula, and it deals with this common difference right here. So I wanted to just kind of go through this formula to kind of talk about what all these mean. So what A of n means, this is our last term value. Okay, so whatever term we're finding, that's the, if we were to find the 50th term, we would consider that the last term that we're finding. So, and that's the value of it. A1, so this is going to just be our first term. That's the term that the sequence starts with, like 2 in our example here. N, this would be the term number that we're trying to find. So in this case, it would be 50. If we were finding the 50th term, we'd plug in 50 there. And then D, what we know from up in our vocab there, this is our common difference. So this is just a sequence. We're adding the same number each time. Even if we're adding a negative, we'd be going down. And so, but a shortcut to find a term way out there, the 50th term, the 100th term, the 1000th term, would be to use this arithmetic sequence formula. So let's go through a couple of examples here. This is obviously a term of 4 numbers, and it says find the next 4 terms of the sequence, then find the 50th term. So the first thing we always have to do is we have to make sure that it's an arithmetic sequence. So here we're adding 6, there we're adding 6, there we're adding 6. So we're adding the same number each time. And just by that pattern, we could pick up, and we can do the next 4 terms. We would say 6, let's see, that'll be 29, and 35, 41, and 47, just adding 6 each time. But now we have to find the 50th term. To find the 50th term, we have to use this formula in the upper right hand corner up here, and we have to plug in some things here that the formula needs. And what I like to do is obviously like to stay organized. We've done this a couple of different ways for different formulas that we've used in this class in the past. So this is A1, it would be 5. Our common difference would be 6, and the term number that we're trying to find would be 50. So we have to plug all those into the equation that we have there. So we would say, instead of A of n, we'd say A of 50 equals our first term, which is 5, plus 50 minus 1 times 6. And this would be, obviously you could plug that into your calculator. I'm going to simplify it just a little bit. We got 49 times 6. And after you plug all that into your calculator, you should get 299. So the 50th term would be 299. And the shortcut, obviously, using that formula. Onto this other example down here. Here, what we would say is we're adding a negative 14. Adding negative 14. And if we were to keep going, negative 3, and then we're plus negative 14, that would be negative 17, 14 more, negative 31, negative 45, and negative 59. So that obviously starting with a of 1 going to a of 7, but now we have to find that 50th term. So we'd say a of 1 is 25. Our common difference in this case would be a negative 14, and our n once again is 50. So we're going to go a of 50 equals our first term, 25, plus 50 minus 1 times a negative 14. So 25 plus 49 times negative 14. You can plug that into a calculator. What you should get out is negative 661. So obviously this example is an example of them going down, starting at 25 and then decreasing by 14 each time. And if we were to keep going, that 50th term would be negative 661. Another example that you might see is they might just give you the first term, the common difference, and they say, okay, go find this term. And it's important that you need to know n, and when they say find a of 12, well, that 12, that's what n is. That's right there. So basically what we write down here in our last examples, all these down here, they have already done for us, so we just have to plug those in. So we say a of 12 equals our first term of 47 plus 12 minus 1 times negative 5, which is our common difference. So here we could simplify this, and well, with this being 11, you probably, hopefully you don't need a calculator. We have 47 plus negative 55, that should be a negative 8. So basically what this means, if we had a sequence starting at 47, going down by 5 each time, so that'd be 42 and 37, and keep going all the way out to the 12th term, we would get to negative 8. Now, one more example that is rather important, it'll save you time in lessons to come, is we're going to take this sequence and write an explicit formula for that sequence. And so what an explicit formula is, basically is we don't have a term number, so we're going to keep this a of n and we're going to keep that n. And so, but we do need the common difference in the first term to do this. So here we're going to be adding 15, and sure enough, adding 15 again. So a of 1 would be 4, and our common difference would be 15, and n we're going to leave as a variable, so we can use this to find whatever term that we want. So we would say a of n equals our first term, 4, plus n minus 1, we'd keep it like that, and then we'd have 15. 15 just like that. So this is a little clunky of a formula, so what we're going to do is we're going to simplify a little bit. We're going to distribute that 15 in. So we have a of n equals 4 plus, this would be 15n minus 15, and then we could combine the 4 and the negative 15 there. So we'd say a of n equals 15n minus 11. And that would be our explicit formula for this sequence. So now we could go through and find whatever term that we wanted. If we wanted to find the 50th term, we could plug 50 in for n. If we wanted to find the 100th term, plug 100 in for n. You want to find the 1000th term, you plug 1000 in for n. So it's a lot faster way of finding the term values that you need. So hopefully this is a well-rounded video of a couple of different examples and really diving deep into everything about arithmetic sequences.